Boom. All right, class, let's go for it. I'm going to do a little bit different here since I have not highlighted this yet. I should have. I'm going to highlight as I go on these here. So let's go with chapter 5. See if there's a yellow in here. Kind of like a yellow in there, kind of like orange-ish. Oh, fill shape. There it is. Let me try this here. Yellow? Oh, no, not that what I want. Okay, I'm gonna leave it like that. Chapter 5, normal probability distributions. And let's jam. What are we gonna cover here? Don't need to write this one down. Today is just an introduction. Maybe we'll get to 5.2, maybe. It's a normal distribution about finding probabilities and then also finding values. And then we have a central limit theorem we're going to explore and then eventually approximate normal contra. Oh, real quick here, honesty question, real quick here. How many looked at chapter 5 prior to coming to class today? Just kind of like scanned it like, oh, you know, that's what I'm going to cover today. Cool. Okay, good. A whole 2 of you. All right. So let's jam 5.1. Okay, introduction and something called the standard normal distribution. What in the world is that? That's what we want to cover now. Okay, we're good. I know some writing out stuff if you need to here, and I'm going to look to see when pens and pencils are down. I know I'm kind of ready to go on, but if I still go too fast, just tell me. I'll come back to it as well. It's no problem. This is for you guys. Okay, so first things first. What are the properties really of this normal distribution here? So properties of the normal distribution are, first of all, it has to be a continuous variable. That means it has to be not the ones that you have a win or loss or the number of people in a classroom. That's not continuous. Number of children in a family. That's not continuous. This would be hours in the day. Yeah, we can break it up into minutes, seconds, milliseconds if we need to. So it has to have an infinite number of possible values that can represent it on the interval. So in this case, time spent studying in a single day, it's going to go from 0. You can minutiate it to the second if you need to. At the most, you're going to have 24 hours because you can't go beyond 24 hours. Second of all, is the probability is also continuous. Okay, good there. And so continuous random variable, also a continuous probability distribution. So you can't be skipping, right? It's not going to skip from 10% to 20% or 0.1 to 0.2. Okay. You guys talking, you don't have to write down all of it. Hopefully not writing down everything, doing the graph and all that stuff. Hopefully just wrote down at least properties of normal distribution. I'll highlight the important stuff. So it has to be a continuous random variable. It has to be a continuous probability as well. Okay, we'll get to the enumeration of the properties here. This is just to start us off with what kind of variables. Okay. All right, I think I see everybody done now. So let's jam. This one, on the next one, this is the only thing you need to write down right here. So the graph of a normal distribution is called a normal curve. And have we seen something like that before? Okay. I don't know why it's repeating itself. I'm going to change it. I'm going to go like this, as I normally do. There it is, and get that out. I'll be able to fit into the previous slide. Oh yeah, much better. So the graph of a normal distribution is called a normal curve. There it is. Normal curve is what we want to see. And yes, it is the most important continuous probability distribution in statistics. See this a lot. A lot of stuff is built upon this normal distribution piece. Okay, this one, I'm not sure if we want to do this. Okay. Yeah, we do have to write down all this. Sorry. Writing down stuff and then we'll stop. It's writing down a whole bunch of stuff here, but these 4 points are important. So what happens here is this, is that the mean, median, and mode are equal. Or we make them equal somehow. The normal curve is a bell shape like this. It goes up, comes back down, and it's symmetric on both sides, and symmetric right about the mean. And I think I want to highlight this one here. The total area. This one actually, I'm going to make it even bold here. Total area under the curve is equal to 1. So I'm just doing a few things here. There. You guys still see that? That is still okay. I think number 3 is the most important one, at least for us to understand. So on a bell-shaped curve, we say the total area underneath this curve is 1. That's important for us to know, especially when we do think about probability. Okay, we're good there. People still writing, go for it. Sorry, lots of writing on this one. I don't think we're going to do. that much more writing as we look at examples here. Okay, and one more thing we gotta check here. All right, notice real quick here, notice this is probably the best way to explain it here. Notice this one right here, as you start, let's say a man is walking right here, right? Walking up the curve. Notice the curve is getting more and more steep. We good? Right here, more and more steep. And then about like right here-ish, right? All of a sudden, isn't this, even though we were still going up, isn't the slope getting less and less steep? Right? So yeah, still going up, but then steeper, 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 steeper. And then about right here, less steep, less steep, less steep. Okay, that little point right there, we call, very important, we call inflection points. So this is the last one. Probably don't need all of that right here, but maybe just that right there. So we have something called inflection points. It's exactly, hey, that's just so interesting. It's exactly one standard deviation away. And so at the points which the curve changes from curving upward to curving downward is called inflection points. What's also important about it is the fact that it's the standard deviation. Or it's one standard deviation away. Okay, cool. So let's talk about the mean and the standard deviation. These little guys right here. So the mu and the sigma issue here. So the mean is in the mean. That should be the most that it happens here. We go out one standard deviation away. We hit an inflection point. Starts curving slower out. And eventually, like right over here, if you think about this as kind of like a grass and an area, like a lawn right here. This guy at 3 standard deviations away, there's hardly any area over here. Is that right? Okay, good. Boom. Okay, let's go with it. Let's now, don't need to write stuff down. Just kind of let's think here. So this guy, if you set up a little bar, in fact, let me zoom in on. Go through each of these here. So notice if we were to set up a scale underneath, and so where the top is, that's going to be our mu or our mean. That makes sense. And then what we do is we kind of look at the curve like this, and we say to ourselves, you know, when does the curve changes from steep, more steep and less steep here? About right there. So that's about 2. So that means the standard deviation is about 1.5 back to the mean. We good? That kind of is easy to sort of see there. And it should be the same on this side because they're both symmetric. So just go one way. So it looks like by 5. So 5 all the way back to 3.5, that should be 1.5. Okay. And remember, standard deviation says how much spread you have, right? Okay, this one, everybody okay there. 3.5 is still the mean, but this time it's scrunched together. And so now this one's about right here, not 2.5. Sounds like a little closer. Maybe like 2, I don't know, 2.8 maybe-ish. Is that right? Does that look about 2.8? there. So 2.8 subtract 3.5, or 3.5 subtract 2.8, whichever. Yeah, 0.7. You can go the other way here. You could say this is about 4.2-ish, right? Maybe 4.3. I would even give you 4.3 here. So standard deviation is 0.7. Okay, and this one really moved off over here. The mean is at 1.5. And again, notice it's the same. Looks like about the same. I'm gonna zoom out just a little quick here. So there's your 3 different pieces. We're good. So you can kind of guess where the standard deviation is. Okay, let's try some. Let's see what happens here. So let's compare curves to each other. So question is, which curve has the greater mean? Well, let's see. Where's the mean on A? That's 15, right? Obviously, right around 15. The mean for B, it's 12. Got it. There's the most. So which one has a greater curve? Obviously A, because A is at about 15. B's curve is about 12. Okay, good there. Again, just examples. Don't need to write this one down. Go to the next one here. Which curve has a greater standard deviation? I'm going to go with B as well, right? Remember, standard deviation just means how much spread you have, right? So if you're comparing spread of things, then B definitely is a lot more spread. But if you want to quantify it, let's try to quantify here. So 15 is here. And then if this one was about like looks like inflection point is about right there. Tell me if you guys agree there, about right there. Like it's like maybe 17.5 maybe, right? So maybe 1.5 away. Or 2.5 away, I guess. This guy's a 12. Looks like the inflection point is happening about right at about 15. So I'm thinking 15 minus 12 is 3. Okay, everybody okay there with 3 being the inflection point. Ooh, I want to see if I can zoom in. That's cool. Okay. Okay, let's jam then. So yes, Kirby has a greater standard deviations further apart, and there's more spread on it. Okay, example here. What's this? Scale test scores, New York State, grade 4, Common Core Mathematics. Not a fan of Common Core, but that's all right. The normal curve shown below represents this distribution right here. So what's the mean test score and estimate the standard deviation? Go. Anybody? Ooh, you can't see. Okay, how about this? I'm going to go to here, and I'm going to go to here. That's 280, right? Looks like, let's see, 30, 40, 50, 60, 70, 80. So this is every 10, looks like. All right, Brian says 305. 305, anybody else with anything different than 305? I'm gonna agree here, because notice right here at 300, if you go all the way up, or your eyes go up, they're still not at the center yet. So you got to kind of come over here. Then at that point, if you drop it down, then you're in between the 2 dots right here. So this is 300, 310, 305. Now the fun part, 305. Can you estimate the standard deviation? So I'm kind of looking down like this, trying to figure out where the curve is changing. It's like somewhere like right here, isn't it? And if you're just slightly off on the standard deviation, that's fine, as long as we're kind of at least understanding it here. Maybe, what do you guys say about right there, maybe? Let's see, maybe curve. Okay, I'm going to drop it down. I think like right here. Is that okay? So how about 1, 2, 3, 4, 5, maybe 50, maybe 45. We're good there. I'm thinking maybe 45 is the standard deviation. Maybe even 40 over here, if it's right over here. I can't quite tell. maybe this one, but I think it's more like just a little closer here. So about right there-ish. Okay. The book, the way the book says it, it's about right here. So it says it's about 40 away. We said 50, maybe it's a little closer here. Yeah, maybe it's this 1, 2, 3, 4. Okay. Are we good there? Okay, so now the question is this. Do you guys remember all the way back to chapter 2? Do you know how much, what percent of the stuff is inside between the first standard deviation away to the second standard deviation? 68, I totally agree. So how about this? So about 68, there's 34% here-ish. There's 34% here. So then grand total, so that means about almost 70%, but 68% of students, or about 68% of students scored between 305, I'm sorry, what is this one here? 28, 7, 265, is that right? 265 and 345, are we good? And that kind of grabs almost 70% of the students. That's a good data set. Okay. Let's jam to this then. Not writing anything down, just kind of going to here. So now we should do this one here. So now let's go to this one. So that was a normal curve. This one, however you want to write it in. The next step in our understanding. This I'm going to erase because there's no need to put that in there. And of course, the formulas, you have to do it. I can't highlight it because formulas don't highlight, only text. So now we call the standard normal distribution. Let's get even more technical here. So what it does, it brings the mean all the way down to 0. And then what it does, it labels your standard deviation exactly at 1 and -1. So that means this is really just based upon the mu at 0, and the standard deviation ways are your integer way values out. That is cool. What do we do with it? Is the fact that we can now make z values of everything. Okay, so you do this one. If you want to draw this out, that's fine. But any x value can be transformed into a z-score, like where are we at in here, by this little formula. So z equals the x value minus the mean value divided by the standard deviation. We'll do some practice items here, but write that down first, and we'll jam with it here. All right, we got quick 4 properties about this, and we'll start finding out stuff. Okay, we're good there. I think everybody hands down here. So got a couple of things for you, some properties to write down again. And important here. So first things first. So now let's talk about the z-score. What does it mean here? So a cumulative area is close to 0, for z-scores that are close to negative 3.49. So that means 3.5 standard deviations away. If you are right here and you get a z-score of negative 3.49, pretty much we say the area underneath the curve is 0. There's no way that even 1% of the population is here somewhere. So once you go beyond a negative 3.49 for a z-score, okay, so what does a z-score do? And what's the connection between the area? So here it is, the z-score, in fact, our tables, the way they're made is, as you increase the z-score is the amount of area that's lower than the z-score. That's kind of what we're looking at. As you increase the z-score, it's the area that is to the left of the z-score. I got 2 more properties here. Almost done with the properties, then we'll do some calculations together here. Got about 2 more people, 3 more people still writing it out. Go for it. So Brian, does it help to have the printout stuff of the lecture? Oh, okay. No suggestion to anybody else in class whatsoever. Okay, are we good here? Euphoria, are we good? Okay. Sure, absolutely. So negative 3.49 z-score means you are way outside of the curve. Okay, 2 more properties. 2 more here. And then we won't have to write stuff down for a little while here. So the cumulative area for a z-score of 0, which is exactly in the middle, which would make sense. If your z is equal to 0, that means exactly half of the area is here, exactly half the area here. So the area would be 0.5. We say 0.5000, just like in science, because it is a matter of precision here. Okay, if you have a z-score of 3.49, a positive 3.49, all intents and purposes, we have captured all of the area here. All right, and raise your hand if you have your textbooks with you. Anybody have text? Okay, cool, good. Okay, so if you want to prep for this here, we're going to go to, I think it's table 4. And on your textbooks here, you should see that table 4 actually has 2 flaps for it. All right, I'm going to demonstrate. Obviously, the people over here on the video cannot see, just people in class. I'll try to do a cutout of it on the next slide here. So let's jam. So here's what we want to do. We want to be able to find the area that corresponds to a z-score of 1.15. 1.15. So notice on your table on your back, notice a few things here. On the bottom of your, I'm going to stand up here and demonstrate over here. On the very bottom right here, notice the way the few things here. So first of all, here's your table. Notice on top, the way the table looks like, notice it's the area less than the z-score, right? Notice on top, it's like a shaded area. Okay, guys, talk to me. Over there. Let me do it like this here. So this one right here. And then Tristan, go there. The shaded area is to the left of the z-score right here. And then we have this bottom one here. It's on both sides. There's symmetry, right? It goes both ways. And so notice over here, we'll talk about it later, but if you have a level of confidence of the z-score of 1.26, you're at 80%, right? You got 90%, so 95 and 99. Just so you guys understand. We're going to look at the top two. One of them has all negative z-scores. That means you're less than the 0, you're in the bottom half, right? Okay, if you flip it over another time, boom, you have all your positive z-scores. Notice what the graph looks like. It's shaded above the mean, right? And it's shaded lower, right? Still lower than the mean. Okay, you guys talk to me, find me 1.15. So downward, you're going to go to 1.1. Good. And then across, you're going to find a 0.05. So added together. So you're adding those things together. A 1.1. And then you tack on the 5 at the end here. So let's see if I can give you guys a screenshot of it. Right here. This is what we're looking for. So on the z-score, we're going to go right here on the second page of it. You're going to go all the way down to 1.1. And then you're still missing the hundredths digit. So then you go over here to that 5 and you connect them together. So 0.8749. Are we good with that? What does that mean? The area, right, to the left of the z-score is about 87.49% of the data is sitting there, of the data or the area is sitting there. Okay. And then of course, get out your calculators here. Let's see if we can do it on a calculator, still get the same answer. So notice the table has only 4 decimal place accuracy. Your calculator has a lot more decimal place accuracy than that. So I'm going to get out my calculator quickly here. Whoa, zoom. Got this one. Okay, let's jam. So we need to find normal CDF. So normal curve and real quick, I got to find it too here. Oh, distribution. Okay, so this little guy right here called distribution is where we want to get to. Right there. In order to get to it, we have to push the second button and click on vars. Out of curiosity here, hold on. Okay. So distribution. And we're looking for this guy here, number 2, normal CDF. Okay, so what this one does is it always asks for 2 z-scores. So this one, we're trying to figure out two z-scores. So the reason why there's a negative, this is negative 10,000. Because we want the first z-score to be like way, way to the left. We're good? Then we climb all the way up to 1.15. Oh, your mean is 0. And then your standard deviation is 1. Because we're on a standard curve. We're good? Okay, and then let me click on this, get the same score, and I'm gonna walk around, see if you guys need help. I'm gonna pause this for while we're walking around here. All right, class, we're good there. I think everybody got it. Okay, awesome. Let's try another one. Let's try, I'm gonna say it first here. Find the cumulative area that corresponds to a z-score of negative 0.24. So hold on, before I give you that, hold on 1 second. Negative 0.24. You guys talk to me. What is the highest this probability should be? Take it. What's the probability that you get over here? What's gonna be the highest? I'm thinking like at the most it has to be 0.5, right? It's gonna be lower than 0.5. How come I say it's gonna be lower than 0.5? Say again. Say again before. Unusual. Okay, gotcha. No, 0.2 is still okay for standard deviation, but this little piece right here, it's a negative, right? Because it's a negative, you're not halfway, right? At 0, you'd be at 50%, right? So negative 0.24, you're not quite at 0 yet. So you suspect your probability or area is going to be less than 0.5. Good. So looking for a 0.4, 0.3-ish, somewhere along those lines. Okay, does that make sense to you guys? I heard a Okay, there's that. On the calculator, you're going to plug it in. So you have to do it kind of both ways here, real quick here. So get out your table. You're going to go to your negative table now. So on your negative table, do it by table first. Negative is 0, right? 0 goes all the way down to 0, 0.2. And then find a 0.04 on the other side. Bring those closer together, What you guys think? I got it, 0.4052. You guys get a raise your hand if you did not get a 4052 by taking. Okay. Not that you found the 4052, but you know how you found the 4052. Okay. You guys talk. Okay. Those did have textbooks? You guys good? Okay, calculator wise, let's go. Calculator wise. You should have something that looks like this. So negative 1,000 again. Punch in negative 0.24, negative 0.24, it wouldn't matter, whether you do or not. And then 0 goes in for the mean, 1 goes in for the standard deviation. But paste, and voila. So this means that the table that we have, it is actually rounded off answers, right? Yes. You got Andy. Upper is a negative 0.22. Your lower one should be negative 1,000. Negative 1,000, negative 10,000, whatever. As long as it's a huge number. Again, got it. First row, you guys got it? Awesome. Cool. All right, and Hugo, did you get it? Cool. Okay, guys, that is cool. We're at 1. Almost done. All right, guys, 3 problems and then one fourth one here. So real quickly here, I think you have plenty of problems to do in the homework here. So let's just kind of run through this here. So we're going to sketch a normal curve. We want to do that, and then we want to sketch the z-score, or write down the z-score, write down the area. That's what we want. So first things first, if you want to graph a normal little curve like that, this is you guys drawing it out now. We good? Can you guys draw it out? And can you guys find me the area to the left of the z-score? So draw out a normal standard curve, right? So it's gonna be a bell-shaped curve, right? The 0 interval is right at the middle, and then you have 1 and -1 coming off the side, or just 0 in the middle, right? And so we want to find the area left of the z-score. So if you're going to draw it out, it kind of looks like this. You label the 0 in, you draw this out kind of like a normal curve. If you want to put arrows at the end, that's customary. You usually put arrows at the end. You usually put a 0 where the 0 is. And then we want to find out a 1.23. I want to find the area to the left of 1.23. Can you guys tell me that? By calculator or by table, whichever way you want. Go. Tell me when you have it, and then round it off to 4 decimal places, so it's gonna be exactly like the table. .8907. We good? Can you guys round? Okay, awesome. So 0.8907 is perfect. Okay, now let's change it up. You guys ready for this? Kind of important, just so we know. I need to know the area, what is corresponds to the right of z. Whoa, hold on. So look at this. To find the area of the right of the z value, all we do is we subtract from 1, right? Our table and our calculator always does this right here. It tells us what's the area to the left. Now this time I want the area to the right of this guy. So anybody with any clue, what should we do? We're going to subtract from 1. Are we good there? So because of that z-squared being there, we know this guy is 0.8907. We knew that from the last slide. So how about finding this? It's going to be 1 minus 0.8907. Are we good? Okay, and then you guys talk to me here. Can you do it like this? So we could do it by calculator. We calculate it. Let me just do it real quickly here. Distribution, normal curve, boom, negative 10,000, 100,000, whatever, 1.23. Mu is 0, standard deviation is 1, and calculate go. 0.8907 is perfect. So chop that off, subtract from 1 physically. We good? Or we could do it like this. Check this out. How about this? How about we go like this? 1. So if you guys can do it in the calculator, subtract. We're good? And now we're going to put it in. So distributive property, so it's 1 subtract this guy. So negative 10,000, 1.23. Standard mean is 0, standard deviation is 1, and voila, are we good? So 1.093. Yeah, I was going to say that's the long way, right? That's the subtraction way of doing it, right? So if you just get the number right here, like we normally did, right? You're going to get a 0.8907, right? If you subtract from 1, you're just going to get the leftovers, which is 0.1093. So on a calculator, if you do 1 minus, exactly how we used to enter it. We'll show a couple of areas here, a couple of things here. And so by table, which is the way I had to do it when I was in class, because there's no calculators there. There's still dinosaurs running around outside. So we had to do it by table. So we did have to mentally subtract everything out in order to do so. Okay, you 4, are we good? Awesome. Now I'm going to show you even easier. Let's go even easier. So how about standard deviation, normal curve? And this time, notice on your guys' T84, it says upward bound, right? Lower bound. So upward bound would be now positive 10,000. Are we good? So lower bound, sorry, guys, real quick here. Sorry, lower bound. 1 second. Clear. Let me do it the correct way. Now your lower bound is 1.23. That's the lower bound. That's the first thing you enter. Okay, your upward bound is going to be 10,000, 100,000, 10 million, whatever, as long as it's way, way, way out there. And then your middle is still 0. Your standard deviation is 1. So now this is actually calculating the right-hand side of the distribution. We good? Do some calculator stuff with you guys. Okay, talk to me if you did not get it. Let me walk around and help you. Then we got to do one more and we'll be done. Okay, so this is really just how much area, right? How much area is now to the right side of 0. So if we tack in like data points into here, right? That would be just how many data points or percent of data points or a proportion of data points that are there. Okay, I'm going to assume everybody got it. Raise your hand if you did not get it. Giselle, do good. Cool. Okay. Andrea, good. Cool. Okay. Tell me now, can you find for me the area between 2 z-scores? I need to know the area right here. I need to know the area that is between negative 0.75 and 1.23. I need to know that area there. Okay, by calculator. Oh no, let's do it the old way. Let's do it the old way first. Let's go by table. Can you guys tell me, according to the table, give me the z-score of, this table's cool. 1.23. Oh, we already have it, huh? This guy, does this guy give you a 0.8907? Is that right? That's the one we calculated before. Is that right? So then So that means what this is saying, the 0.8907 is the area that's to the left of this guy, right? That's what it's saying. Good there? Right, it's the area from here all the way down. That's what we're saying. But we don't want this. We don't want this tan area here. We just want the blue-green area. We good? So now we have to subtract out this extra piece here. So can you guys go on your calculator or the table? Actually, by table. Sorry. So 0.8907. Can you guys give me the area that corresponds to z-score of negative 0.75? Two, 266. Are we good? Okay, so this 0.8907 gave us the area from here all the way down like this, right? It gave us that area. We don't want that area because we don't want that tan space there. We just found out from negative 7.5 that the area here is 0.2266. So let's subtract those two. We good? We're subtracting those two because we're taking off the extra area to the left of negative 0.75. And we find out that to be, there it is. So the area just here, and tell me if I added or subtracted correctly. Are we good there? Did I subtract correctly? Oh yeah, sorry, it's 2266, right? Okay, thank you. So that's a 1, borrow, that's an 8, that's a 10, 4, 6, 6, so 0.6641 or 66%-ish. Okay, by calculator. Let's do it by calculator now. Calculator's way easier. Screen, show taskbar, group. So by calculator, we're gonna click on this guy. Man, you guys don't even need to calculate stuff like I used to do. So this one, we're gonna lower bound is gonna be a negative 0.75. The upward bound is gonna be a 1.23. 1.23. My mu is 0. My standard deviation is 1, and click enter, and let's see what we get. Ooh, we're off by a little bit, huh? And so notice if you're off by that 10,000th, it's just because of rounding error between the table and your calculator. We're good, so it's just a little bit off. So this one would be 0.6640 as opposed to 0.6641. Okay, talk to me, does that make sense? So we found the area in between two z-scores, one by subtraction of the two areas and one just by calculator. Okay, one final one for you guys to finish off on. Can you guys give me this one? What we'll finish off on. All yours, go. Give me the area underneath the standard normal curve from a z-score of negative 1.5 to 1.25. And I think on the homework, it makes you do it by table. So if you're off by that 10,000, just know that. All right, we'll finish up with this here. So tell me if you get something that is off. I'll give you guys about 20 seconds. Try it yourself first, though. Go. And then I'll show you the answer. Okay, so your lower bound, lower is going to be a negative 1.5. Your upper bound is going to be a okay, I got one person with the answer already here, so let me show the answer. Ooh. Let's see. Okay, guys, I think we learned something new. We learned something new today. Okay, if you still haven't got it, wait for me. Otherwise, we are done with 1.5.1. We'll start with 5.2 next time.